Hello students, today I am going to teach the topic Media Cloud. So let's proceed with the concept as a Media Cloud. It is also referred as multimedia cloud computing. Distribution of multimedia content has always been a fundamental issue for media service and content providers. The large computational storage and bandwidth capacity of the cloud make it a very attractive platform for multimedia applications. Further, large public cloud often have many strategically geographically located data centers, allowing for more efficient distribution of content. Multimedia cloud computing and general purpose cloud computing share many commonalities. However, multimedia services are highly diverse. Examples include voice over IP, video conferencing, and video streaming. So, multimedia data are the major form of data available in the internet nowadays. In the case of videos, there are wide variety of formats available. Storing and processing multimedia data require a large amount of processing and storage facilities. The currently emerging technology, cloud computing, can be utilized to efficiently process and store such data. Media Cloud provides storage for media data and also enables the presentation of data using media signaling protocols. A simple multimedia cloud consists of different kinds of services like an video conferencing, video streaming, and voice over IP. Media clouds provide distributed processing of multimedia data and provide service with high quality of service for multimedia data. The content stored in a media cloud can be easily streamed to various clients such as music players in cars and smartphones using protocols such as Transmission Control Protocol, that is TCP, User Diagram Protocol, that is UDP, and Real Time Transport Protocol, that is a RTP, which are a core part of this media cloud computing. As modules and their relationship in a multimedia cloud computing as depicted in this picture. In the multimedia cloud computing, which consists of a storage, editing the videos, content conversion, and content delivery. Now, this is a cloud media and this is a media cloud. As we know that nowadays there are different media clouds are acting in today's scenario. Let's have one good example for this. We are using different social media portals like an Facebook, then Twitter. Also, we are using different career oriented social media portal like an LinkedIn and Naukri. So, in this such a social media portal, what exactly you can do? Simply, there are number of user gets connected with each other with this social media platform. In this, I will add one more word, that they got connected with the help of this cloud media. Now, when number of user gets connected with the help of this cloud media on a cloud, that is called as a cloud media computing, where they can share information, they can post the data, they can upload the videos. With this, they can also broadcast their information. This all the things are a part of this media cloud. As everywhere, whenever any user is going to do multimedia related tasks, so definitely they require a huge amount of storage. Also, number of users will go with an editing of the certain task. With this, some users will go with the content delivery. Now, for everywhere, they require certain storage. With this storage, they also require a fast access of the data from everywhere. Now, for doing this fast access of a data, also to get a large repository to store huge amount of data, there is a one and only one solution, that is called as a cloud. And as I am embedding this cloud into the media, as well as combining this media into cloud, the new concepts form as a media cloud. Now, as we know, a simple example of social media portal like an Facebook, where billions of user gets connected with each other. So definitely you can judge that how much amount of data gets generated day by day. So where the data gets managed, that is one of the important thing. Simple answer is the data gets managed behind in a one large repository, that is called as a data center. As we know, in a data center, they are going to maintain the data by giving a security or a protection to every user's data, and the store data which is of different category. Under that, we can store different kind of multimedia data, which can form of different video conferencing, videos, audios, text information, or images, and that is also available to user whenever they need. So on a cloud-based platform, they can easily access that data. As we know that for this multimedia, there are billions of users. So if applications are available on a cloud, which is referred as a media cloud, then how their management is possible? There is only one answer for this question, is this management is done with the help of load balancer and resource allocator. As number of user gets increased to access the media cloud with the help of cloud media, then they simply implement concept of load balancer. So every accessing request as well as assisting to the each user who got connected on this media. So this is a modules and their relationship in the multimedia cloud computing. As we say that it is an cloud assisted media sharing, that media sharing and distribution services are evolving extremely quickly. New services and applications are being developed constantly. Some become hugely successful, like a YouTube, many other fade into obscurity. Developers face a trade-off in the early stage of any multimedia services. How to provision enough resource to provide a high quality experience to their current users, as well as allowing room for the user base to grow while not overextending themselves on costly infrastructure project and overhead. Also, the cloud's pay-as-you-go service allows a service to start small and scale large without huge initial capital investment. The main thing which want to talk about this media cloud is that here, as per the other cloud services or any other cloud areas, here also we can proceed with pay as you go subscription. But again, there is a one beneficial in terms of users, in terms of media sharing, that as suppose any user has created their YouTube channel, and with the help of that channel he or she can upload them videos on a YouTube, and also whatever YouTube videos uploaded by them, they gets available, they gets published, and which is available to the end user, so that it is easily shareable. That is because of the media cloud. Now, as we know that there are number of big companies, big organization who acquire huge amount of space in this media sharing. Even if the number of media publications, publishers are also acquiring this media cloud for their different business processing. As we know that they are acquiring this media cloud, it means that they are using the cloud services in terms of a media cloud. So when they are going to adapt such cloud services which gets implemented for their media cloud, definitely they will go as per the subscription, that is a pay as you go platform, where their plan will start with very affordable rates, which is a very beneficial for their end user, as well as it is affordable to their customers. So in this way the cloud assisted for the media sharing. Let's talk about this generic framework of media streaming, how this work and how it is possible. It's one kind of framework or one kind of architecture. We can see, as in this picture we can observe, these are the two layers. One is a cloud layer, another is a user layer. In the user layer we are get located number of user gets present who got connected with this cloud. As know that these are the various regions like Asia region, then Europe region, Australia, South America, and North America. Now here everywhere you can find there is a presence of cloud server that is not being leased. With this there are main cloud server which is being leased. So two kinds of server have been implemented in such framework, that is cloud based server which is being leased and some cloud based server which is not being leased, and that is present in every kind of location of this globe. As we means user gets connected with this different kinds of cloud based server, that which can interpret that for the migrating live media streaming services to the cloud. Here, for example, suppose youtube.com is one of the portal through which we can share your videos. Also, we can do a live streaming of your data or do the broadcast of these things. So it means that the user gets connected with this server in North America. So they are not only connected with the server, with the help of some cloud-based lease server, also the same data get broadcast to the Europe-based server, Asia-based server, Australia, as well as South America. So because of that, everyone can share their multimedia data throughout this media cloud. So this is a one kind of framework which got implemented for the streaming. So it's not like that you feel any kind of delays or kind of buffering while seeing the videos with the help of this media cloud. But there is only one condition. What is that? You require good bandwidth, good internet connectivity. Then and then this streaming, then you can broadcasting is easily possible with the help of this media cloud. Now let's have one case study of one of the implementer or organization who implement the media cloud. That is a Netflix. Nowadays this Netflix is become very much popular, as we know that this is basically one kind of portal where you can get number of web series, movies, any kinds of tutorials, then video games and all. So in this scenario, which was the one successful organization who implemented a media cloud. So in this, it's combining the huge network traffic requirement and dynamic unpredictable demand burst. Netflix has become a prominent example of business greatly enhanced by multimedia cloud computing. As of 2012, nearly all of Netflix media infrastructure has been moved to the Amazon public cloud. So they are having previously their own servers and all. As day by day data gets increased, number of user gets increased on the Netflix, they require a big cloud infrastructure, as well as they require a good data center so that they can broadcast their program, so that they can properly act as a good web media. So they got shifted onto one of the cloud service provider whose namely as a Amazon public cloud, and we are using that services nowadays, that is a Amazon AWS. Then Netflix leverage Amazon's cloud services to provide the following features like an content conversion, then content storage and content distribution. In the content curation, that is, we can say in this conversion using EC2 to support or to convert master copies to over 50 different versions with varying levels of video resolution, video quality and audio quality. So these features Netflix has get because of this cloud service provider, as they have implemented the switch their platform towards the Amazon public cloud. Also they will get features, they received features in terms of content storage, that is utilizing S3 to store many converted copies. As we know that if you see the Netflix database, it's a very huge number of articles, number of videos, contents. There is a big huge video library are a part of this Netflix. With this, Netflix also get a benefit in terms of content distribution. Now you can say at every person, at every home, if you see, they are having mostly 80 to 90% reaching of the Netflix media. So data is distributed from S3 to various CDN, that is content delivery network, which is also part of cloud service provider, where the media is ultimately streamed to the end user. So this is one of the best case study of the web cloud in terms of the Netflix. Then also a web cloud performing well role in terms of interactive cloud gaming. As we know that it's not limited to every user that they can only play games on their smartphones and all, which got installed in their machines or in their smartphones only. Also a user can initiate, also user can interact with some cloud-based gamings also. So cloud gaming at its core usage thin clients to interact with powerful cloud-based servers to render interactive games remotely and stream the images back. So you don't worry about installing the specific games on your smartphones, PCs, or your laptops. Simply get an cloud subscription for the gaming and you can play game on a cloud base. Many of the today's top interactive games require powerful desktop class components to provide an enjoyable gaming experience. Many relatively weaker devices such as a tablet and smartphones do not meet the minimum requirement. For such a case, there is one solution with the help of this web cloud or media cloud, that is a interactive cloud gaming. Let's have one example for that one. Suppose any game required a good high-end graphics, they required the graphics cards and all these things or good system configuration, but it may happen that somewhere these configurations are not present and also it is not affordable to their users. So in that case, that user is going to away from to playing such a game. No, simply if they are having good access connectivity of the internet and they have subscribed for the cloud gaming, simply they can play different kinds of games on a cloud platform. So this is a interactive cloud gaming. So there are many challenges to the media cloud. The challenges come in the form of heterogeneous formats available for different types of multimedia data, heterogeneity of application, scalability to adapt to newly developed form of media, and at the same time making the multimedia cloud a profitable cloud. For increasing the profit, the risk of failure should be decreased. As in the architecture of the media cloud, which consists of storage subsystem, ingest services, then media cloud admin, then streaming services, then video services. Finally, all these things are work together to achieve the goal of the media cloud. As there are main 5 components of this architecture, that is a cloud administrative services, ingest services that accept media input from a wide range of sources, then streaming services, then video services, which is basically used to manage and deliver video across media channels to various clients. Then with this, storage subsystem for content cache and movement, storage and access management. The only solution to the busty increase in multimedia in coming years will be cloud computing. The cloud will be major host for all multimedia data and multimedia processing in the near future. In order to make the system less complex, an approach that transforms the heterogeneous type of audio, video, and other multimedia data into a standard format is more desirable. The area of media cloud has various unresolved issues such as media cloud architecture, then storage, then delivery of multimedia data, then mobile broadcast, energy, efficiency, and media mining that involve information retrieval from multimedia data. The media cloud can also use for provisioning to meet video on demand requirement. So this is one of the on demand requirement, that is meet the video is one of the specification features of this media cloud. As we know that nowadays any movie has been released, so there few years back there was an trend that it got allow in the multiplex, it got first released on multiplex, but nowadays everyone having good internet connectivity at their homes. Because of that, they can only see first promo as well as release of this any kind of series or movies on the internet itself on home while using their gadget like a desktop, PC, or smartphone. They can deal with such media cloud. So there are tremendous benefits of this media cloud as one of the media cloud computing. Thank you.